like the fuzzy part of Velcro. It's like a furry or fuzzy part on the bottom of the cells. That's the basal lamina. These are made of glycoproteins and glycolipids. This fuzzy part is made of glycoproteins and glycolipids. Remember glycoproteins and glycolipids? Those are proteins and lipids with what? Carbohydrate hats on them, yeah. And it makes like a fuzzy or fur, especially along the basal surface of the epithelial tissue. The reticular lamina consists of collagen fibers. Coming from the connective tissue underneath. Reticular lamina, like the hooks on Velcro. So you got the fuzzies, you got the hooks. The hooks attached to the fuzzies, and that keeps the epithelial tissue stuck to the connective tissue underneath. Together, these two things, basement membrane. Together the basement membrane. That's how they stick together. So your skin stays stuck to your body. Make sense, everybody? Okay?
Can you repeat the definition for reticular lamina?
The reticular lamina is the collagen fibers that come up from the connective tissue underneath. Reticular lamina. These collagen fibers that are coming up from the connective tissue underneath. You okay? Avascularity means they don't have any blood vessels. They're avascular, there are no blood vessels. They are, or let's say they can be innervated. They can be innervated. What does innervated mean?
Nerves?
Yeah, it has nerve endings in it. Some of them do, some of them don't. Simple squamous epithelium, no, it's not innervated, but your skin sure is. So some of them do, some of them don't, but they can be innervated. And they have a high regeneration capacity. They grow a lot. They grow well. Your stomach gets a brand new lining every 6 or 7 days. Brand new stomach lining. They reproduce a lot, they grow a lot. High regeneration capacity. Everybody okay? Now you guys should all know how these guys are classified. Page 118 and 119 in your book. Get it out, please. Page 118 and 119. The first thing you look at is how many layers of cells are there. If there's one layer of cells, it's a simple tissue. If there's more than one layer of cells, it's a stratified tissue. One layer is simple, more than one layer is stratified. Next up, the cell shape. Bottom of page 118, you can see squamous is flat. Cuboidal is about as tall as it is wide, and columnar is taller than it is wide. Cuboidal is shaped like a cube, columnar is shaped like a column, squamous is shaped like a fried egg. Have you all had that much in lab? Everybody's okay. Do you need any more clarification of any of that? All right. Let's start with a simple epithelial tissue. Simple squamous epithelium is found in your kidneys, in your lungs, lining your heart and blood vessels, lining your heart and blood vessels, and also serous membrane. Remember visceral and parietal flora, visceral and parietal peritoneum, visceral and parietal pericardium. Those are all simple squamous epithelial tissue. Those are all one layer of flat cells. Now I'll give you guys some special names. Endothelium means inner covering. Endothelium means inner covering. And that's a fancy name for the tissue lining your heart and your blood vessels. That's a fancy name for the tissue lining the inside of your blood vessels and lining the inside of your heart. Endothelium. Yes, it is a simple squamous epithelium. Endothelium tells you where it is. Lining the blood vessels, lining the heart. Mesothelium means middle covering. And there you're talking about the tissues that line your body cavities, your ventral body cavities. That's another name for the serous membrane. Mesothelium. Yeah, like your visceral and parietal pericardium, you could also call them the mesothelium. It's like a general word for all of those guys. Now, functions of simple squamous epithelium. It allows for diffusion across the membrane. It allows for diffusion across the membrane. This makes up your lungs. It also does filtration. Simple squamous epithelium is going to be filtering the blood in your kidneys. And it also secretes material, like in the serous membrane system. They also secrete material in the serous membrane system. Remember, serous membranes produce that lubricating fluid so your organs can kind of slide around. They don't get stuck to each other. Everybody good? Simple cuboidal epithelium. That's found in kidney tubules. That's found in kidney tubules and glands. Found in kidney tubules and glands. That secretes or absorbs material. That secretes or absorbs material. By the way, you can see some simple squamous on 119, some simple cuboidal, and some simple columnar on page 120. Simple columnar can be ciliated or non-ciliated. Simple columnar can be ciliated non-ciliated. Ciliated simple columnar can be found in the respiratory tract, the reproductive tract, non-ciliated can be found in your digestive tract. Non-ciliated can be found in your digestive tract. Simple columnar epithelium also absorbs and or secretes different materials. They also absorb and or secrete different materials. Sometimes you'll find goblet cells in simple columnar epithelium. Sometimes you'll find goblet cells there. What are goblet cells? What do they do?
Mucus.
Yeah, they produce mucus. Good. Goblet cells produce mucus. And then there is pseudostratified columnar epithelial tissue. Pseudostratified, that's probably the one that's been giving you guys fits. Pseudostratified is a simple tissue. Remember, pseudo means fake. Pseudostratified is fake stratified. It's really simple. All of those tissues connect to the basement membrane underneath. All of those tissues connect to the basement membrane underneath. Pseudostratified can be ciliated or non-ciliated. In my lab classes, which kind are you going to see?
Ciliated.
Ciliated, yes. Ciliated tissues found in the respiratory tract. Moving mucus. Non-ciliated is found in the ductus deferens. Non-ciliated is found in the ductus deferens. You guys all know where your ductus deferens is? How many of you think you have a ductus deferens? Yeah, it's also known as the vas deferens. You know what that is? That's the tube that carries the sperm from your testes to be ejaculated. That's what gets snipped in a vasectomy. Vasectomy cuts the vas deferens or ductus deferens. Stratified epithelia, more than one layer. Stratified squamous epithelium, that is found in your skin. That is found in your skin. It resists abrasion. It resists abrasion. There's actually two different types, keratinized and non-keratinized. We're going to get into that a little more when we do chapter after the test on skin. Keratinized is on the outside, non-keratinized is on the inside. Basically, if it's dry, it's keratinized. If it's damp or moist, then it's non-keratinized. How many people hate the word moist? Okay, I'll try to use it as much as possible. Sorry. Stratified squamous is your skin, resists abrasion. Stratified columnar and stratified cuboidal. Both of them are rare to non-existent in humans, and they will never be an answer, test or quiz. Stratified cuboidal or stratified columnar will never, ever, ever be an answer on a test or quiz, because they are rare to non-existent in humans. Let's see how many guys paid attention to that. Transitional epithelium, if you look at 122, it's kind of domed on top. It's definitely a stratified tissue, multiple layers, but it's domed on top. It looks kind of like this. Why do you think it's going to be domed on top like this? That's a good guess, but not exactly. Yeah, it's going to stretch. When you stretch it, it goes like this. Transitional epithelium is very stretchy. It's also very waterproof. Very stretchy and very waterproof. Which is why it's so good at making up your bladder. That's where you find it. Bladder and urinary tracts. It is stretchy and waterproof. So it makes up the lining of the bladder and ureter. Everybody okay? How we doing? All right. Connective tissues. There are 4 main categories of connective tissues. Wait. We got to do glandular epithelium, don't we? Yeah, it's getting ahead of myself. I apologize. Glandular epithelium function is one or more cells that secrete a particular product. Glandular epithelium is one or more cells that secrete a particular product. It can be a protein, it can be a lipid, it can be a steroid. But it produces something the body needs. Now, glands can either be endocrine or exocrine. Glands can either be endocrine or exocrine. Endocrine glands don't have any ducts. Endocrine glands do not have any ducts. They are ductless. That's D-U-C-T, not D-U-C-K. There are no ducts. They secrete their material directly into the bloodstream. Exocrine glands have ducts. Exocrine glands have ducts. Take a look at page 125. There is a fancy picture of the tubular secretory structures and alveolar structures. So if I was to draw one of those on a test, would you be able to identify it? Totally left on the people learn that.
Oh my
Don't
God.
do it. Alright, just know they have ducts. Exocrine glands have ducts. Now I want you to look at something weird. On page 124, there's a goblet cell. There's a goblet cell. Remember, goblet cells make mucus, right?
Mm-hmm.
For some reason, I don't know why, they classify that as an exocrine gland. Classify that as an exocrine gland. It's a unicellular exocrine gland. It just is, and I don't have a good reason why. It's not an endocrine gland, it's an exocrine gland. It produces a protein called mucin. And mucin really is instant mucus, just add water. Now take a look at page 126. There are two different methods of secretion for glandular cells. There are three listed in your notes. Everybody see apocrine? Go ahead and cross that off. That's a weird one where the whole top of the cell pinches off and floats away. That may or may not be in humans. Depending on who you talk to, so that's another one, just cross it off. Two different ways cells secrete: Merocrine style secretion or holocrine style secretion. Merocrine style secretion means the cells do exocytosis. The cells in those glands do exocytosis to secrete whatever it is they're making. Pancreas, sweat glands, and salivary glands all use Merocrine style secretion. Pancreas, salivary glands, and sweat glands all use Merocrine style secretion. In holocrine style secretion, the cell itself blows up and dies. It fills up whatever it is that it's making, and it pops. Those are your sebaceous glands. Sebaceous glands use holocrine style secretion. What's another word for sebaceous glands? You're close. Oil glands, yep. These are oil glands. You know when your face is oily? That's because all those cells blew up and died. Poof, pop. So you've got nuclei on your face, you got mitochondria on your face, you got all that stuff all over your face. And you have sebum on it. Sebum is a fancy word for oil. Sebaceous glands make sebum. Any questions? All right, connective tissues, four main categories. Take a look at page 127. This could be kind of daunting at first, until you realize blood is its own category, bone is its own category. There's three kinds of cartilage, group all them together. Everything else is connective tissue proper. Everything else is classified as connective tissue proper. Blood, bone, three cartilages, and everything else. Common characteristics of connective tissue. They all have a common origin. They all come from the same place, same layer. In lab, I talked about spoon baby. Take a look at page 1103 in your book. Page 1103. You didn't bring that part of your book with your neighbors. You don't really have to get it. Page 1103, you can see what a 16-day-old embryo looks like. There's actually three layers. There's actually three layers there. Mesoderm is the middle layer. come from the mesoderm, the middle layer of 16-day-old baby. Connective tissues have different degrees of vascularity. Some are really vascular, like bone is really, really vascular, lots of blood vessels in bone. Others, like cartilage, are avascular. Cartilage has no blood vessels in it. That's why it takes a long time to heal cartilage injuries. Not much going on in there. Connective tissue also consists of an extracellular matrix and scattered cells. See this right here? A crude drawing of connective tissue. These are cells. And all the rest of this stuff is extracellular matrix. Extracellular matrix is the stuff outside of cells. Here in epithelial tissues, it's all cells. So remember he said it's cellular, it's very cellular. It's all cells. Down here, there are cells with extracellular matrix around them. Everybody okay with that? Make sense? Now, extracellular matrix consists of ground substance and fibers. Write that down. Extracellular matrix equals ground substance plus fibers. There's an equation for you. Extracellular matrix equals ground substance plus fibers. Ground substance is the jelly-like goo between the fibers. Ground substance is the jelly-like goo between the fibers. It's a lot like Jell-O. Actually, it is Jell-O. Gelatin. You guys made your own chicken stock. They cook the chicken for a while, let it simmer on a stove for a couple hours, and gets all the good stuff out of the bones and the cartilage and stuff like that. That is ground substance. You know how they make regular commercial Jell-O? They take the cow carcasses that has all the meat stripped off of them. You got the bones and the cartilage and stuff like that, and they boil that and they chemically treat it. You get the scum rising up on top and stuff like that, and they extract the gelatin from there. They put a little bit of lime flavor, a little bit of sugar in there, and that is Jell-O. So if you're thinking you're vegetarian and you're eating Jell-O, not so much. That is boiled cow carcass. How many guys have ever used the unflavored gelatin to thicken stuff up? It's Knox blocks, you can get it in the store. If you're making Jell-O shots, I didn't tell you this. If you're making Jell-O shots, throw an extra thing of Knox gelatin in there too. It makes it nice and stiff. And it's not all sloppy. You can slam a lot of vodka in there, you know. Some unflavored gelatin in there. One of these days, I'm going to make some chicken Jell-O and surprise some people. Get some like chicken bouillon and put some unflavored gelatin and make chicken Jell-O and make a shot out of that. So see what people think about it when they eat it. I actually used to do stuff like that. How many guys, or I think BuzzFeed has one, but there's a bunch of other things. The Jell-O molds, the weird, crazy Jell-O mold that used to be meals back in like 60s and 70s. They put like salmon in Jell-O and ham in Jell-O. It's called aspic. You ever cook a turkey or a ham and leave the juice in, put it in the fridge, and next day you pull it out and it's solidified? That's aspic. I mean, that is ham Jell-O and turkey Jell-O and stuff like that. We used to see some really weird stuff. Google it sometime. Jell-O molds. Google savory Jell-O molds. You'll see some stuff and we think, dang, we would never eat that. That's why we don't eat it anymore. But anyway, that's the ground substance in the connective tissue. That's why you make stock. That's why stock is so good. It's got a nice mouthfeel. It makes everything wonderful. Ground substance has interstitial fluid. What's interstitial fluid? Fluid in between cells, right? Anytime you see interstitial fluid, it's fluid in between cells. Adhesion proteins attach the cells to the matrix. Adhesion proteins attach the matrix. Proteoglycans. Take a wild guess. Tell me what proteoglycans are made of. Protein and
sugars and
sugar, yeah. These are big, almost feathery looking molecules that hold a lot of water. They form the jello stuff. So that ground substance is the jello that's in your tissues. And then there are fibers in that jello. Take a look at page 128. There you can see the different fibers in different cells. Connective tissues are a lot like jello mold. With a bunch of jello, with a bunch of stringy things and blobby things in them. Those are connective tissues. Take a wild guess. Tell me what collagen fibers are made of. Collagen. They provide strength and toughness to a tissue. They provide strength and toughness to a tissue. Make it hard to pull apart. You might see collagen called white fibers sometimes. They provide strength, toughness. The tissue. Take a wild guess and tell me what elastic fibers are made of. Elastin, yes, elastin. What makes up? Elastic fibers. Elastin is stretchy like a rubber band. It's stretchy like a rubber band. It provides elasticity to the tissue. It provides elasticity to the tissue. So the tissue can be stretched and spring back. Stretched, spring back. Now, take a wild guess. Tell me what reticular fibers are made of. It's a good guess, but it's collagen. I did that on purpose. I apologize. Reticular fibers are also made of collagen. They have lots of branches. They have lots of branches. They form like meshes or networks. They also help make up solid organs. They also help make up solid organs. You had this in lab already. Remember what they look like? What do we say collagen reticular fibers look like? Net or tree branches. Remember tree branches? These guys kind of provide bleacher seats in solid organs. They provide bleacher seats. You guys have all seen bleachers before, right? These are places for white blood cells to hang out. Watch and see what floats by. So they provide structures for white blood cells to hang on to. Lots of branches. And then there are cells. Permanent cells, cells that are in these tissues all the time. So we talked about this in lab before, but I don't think everybody got it. What cyte means? C-Y-T-E. What's cyte tell you? It's a cell. It's a mature cell. So an osteocyte is what? Mature bone cell. Hepatocyte is what? Mature liver cell. Chondrocyte is what? Mature cartilage cell. Mature cartilage cell. So remember, C-H-O-N-D. Cartilage. Every time you see chond, it's cartilage. A blast is a baby cell. B-L-A-S-T, blast is a baby cell. But it's not like 3-month-old baby that does nothing but eat and poop. It's an active cell. that does lots of stuff. So what's an osteoblast? A baby bone cell that builds bone. These blast cells are active, they build things. Osteoblasts build bone. What about chondroblasts? What are they? Cartilage cells that build cartilage. Take a wild guess and tell me what fibroblasts do. Make fibers, yes, good. Fibroblasts make fibers. Make collagen fibers. Fibroblasts make fibers, specifically collagen fibers. Adipocytes are fat cells. They store lipids. They store lipids. Store energy. Chondroblasts found in cartilage, they make cartilage. Osteoblasts found in bone, they make bone. You guys knew that already. Hematopoietic stem cells, they become all the different kinds of blood cells. They become all the different kinds of blood cells. They can be red blood cells, they can be white blood cells. Anybody know how many different kinds of white blood cells we have? It depends on how you divide it up. You can do all kinds of stuff. There are 5 basic ones. There's like 4 different kinds of lymphocytes. So you can get like a ton of different cells, but they all come from hemocytoblasts. There's also megakaryocytes. They make platelets. What do platelets do in your blood? You should know this. Platelets clot blood. Accessory cells, white blood cells just passing through. These guys are parts of the immune system. For now, we can call them immune system components. We can say they fight off foreign invaders. In Pt.2, we're going to get a lot more specific. In Pt.2, when we do immune system. So my Pt class, just going to get into that. There's a lot of stuff. It's actually really cool. But for now, white blood cells fight off foreign invaders. We're good. Plasma cells produce antibodies. Plasma cells produce antibodies. We talked about antibodies, right? Kill these signs on the cells, on the bad guy cells. Mast cells release histamine and heparin. Mast cells release histamine and heparin. That causes inflammation. I'm going to make you guys write one more thing down, and we can talk about this next class. I want to get this at least down on paper. Macrophages do phagocytosis. Macrophages do phagocytosis. They are the eating machines. They're going to clean up the garbage. Mast cells produce histamine and heparin, cause inflammation. Macrophages, eating machines, do phagocytosis, clean up the garbage. All right, how are we doing? Everybody okay? Questions, comments, concerns? Next class. I'll tell you what's going to be on the test, so make sure you show up for that one. All right? Slide E3.